I thought I would. Wait, no. Okay, sorry. We're back. So I thought I would quickly show how to use Scale ACC, which I didn't show.
By the way, something that came up during the break. Probably don't have in your run directory the ACC file and the RSF file that we discussed. And the reason is that the default case we told you to run runs for the first day of the month, so it does not cross the month boundary, so the files have not been created. So if you want to see them, you can do it as an exercise. Change your I file, restart the model as a regular submission, and let it finish the end of the month, and then you will have those files.
Well, this should be, I guess, partial. If that was normal restart, it should be partial file.
The partial, yes, but not the ACC.
Yeah, but we can look at the partial file. That's
yeah, we can
partial
look at the partial.
It's the ACC file by format.
Yeah, the partial.
Okay. Anyway.
It's just that.
Yes, but not RSF, but not the RSF.
I'm not.
All right. So to generate one of these diagnostic files, I'll just type an example here for people to see. So you use Scale ACC, as it was said. If you generated 1 month of data, which probably most of you didn't, you only have the partial file,
which is the output after the first time step.
The first time step.
Regardless of how long your setup hour is,
right.
The partial file is after the first time step.
Right. So if you run Scale ACC,
no, first time step. Yeah.
Partial ACC file.
Right.
If you run this command, you will now get a file called partial AIJ. If I run the same thing on the December, I actually did run the model for 1 month. Yeah, Scale ACC, yes. AIJ, again, I can get a December 1949 AIJ file. Let me go back to the main screen now, just so I showed you how that worked. There are a slew of diagnostics that you can use. So the AIJ file I just mentioned is what we call the atmospheric diagnostic output. So it's 2D, latitude and longitude variables. And there are a whole slew. So we have attempted to put some documentation together to explain what these variables are, because nobody on the Earth side ever did. So we made some effort in the ones that we have most commonly used, and those links are here, and hopefully they still work. We generated these last year. So if you want to know what the diagnostic output is from these AIJ files, you can go to this document, it'll tell you what they are. The same for the AJL, and I think we also did for the AIJL, it looks like. So these are all the atmospheric ones. Anything these with A are just different kinds of atmospheric diagnostic outputs. Typically, I would say most of us here, most of the time, just look at the AIJ file for most of the things we're interested in. For example, I want to know what the surface temperature of my world is. That's called T-surf. That's in the AIJ file. We can take a look at that quickly a little bit later. There are also ocean dynamic outputs, very similar in syntax to the atmospheric outputs, and those begin with O, obviously. OJL, OIJL, OTJ, all kinds of stuff there. And there are some other things which are not well documented, and I have never used them myself. Things like these tracers ones, maybe you have used some of the tracers ones. Yeah. TAJL, TAJ. If you want to use those, you can talk. And then, of course, there is an option. If you want to get all the diagnostics, you type Scale ACC, the name of your ACC file, and all, and it will generate every one of these files for you, and you can play with them to your heart's joy. I think, let's see, come on. Oops, it's skipping again here. I think we've already talked about the planet params. We're not going to talk about diagnostics. Do you want to talk about these top two things?
I want to mention like the first line that we keep so far. This include rundeck ops. You will see this file, this line nearly in all Fortran source files. And basically, what it does, it actually includes those the processor options which you specify in the rundeck, specifying this line in your source file basically tells, just include that piece of information from the run deck as it was there into your Fortran file. And you need to do it if you want to use any of those CPP flags in your source file. So that in most files it's already there, but if you're modifying the code, you should be careful.
Yeah, or if you create new files
and if you create new
and
files,
you want to one of those defined statements in the run deck to be applicable in your file, you need to put this line at the very top of your
file. Maybe
I would skip the rest.
Should we skip the rest? I think it's the rest not so interesting. And I thought I would just quickly.
The FACC is useful.
Yeah, maybe it should be mentioned because that's probably the only file which users may want to modify.
Yeah.
It's self-explanatory. I mean, if you really want to hack the code, you will figure it out. It basically specifies like.
Says the man with the most experience of hacking this model in the building. Yeah.
Well, it has lines which specify basically like 1,000 or more of diagnostics, and you will see like for each diagnostic there is a section. Which basically what you do, you just find the diagnostic which is similar to the one that you want to add. You copy the section and you modify it. Modify those things which you understand and leave it as
in other words, don't touch this file.
The things which you don't understand.
Everybody just email you.
Okay, and I thought very quickly we can just take a quick look and then we can take some questions and answers at one of these AIJ files that I created. I will first open it. I will stop this share and I will go back sharing. So this is how you on a Mac anyway. I'm not sure Linux would be a bit. Just open the AIJ file. Open December 1949, and if you have Panoply installed, which hopefully you did install, I'll have to share this window now. I'll show you the window that popped up.
Well, on all other systems, you just start Panoply, and then you use like file.
Panoply and file name. That's right.
Nice.
So hopefully you guys can see, you all can see this, and I thought I would just the most commonly used one, as I said. There are literally hundreds of diagnostic things in here, all kinds of stuff, most of which most of us have never ever used, but they're all kinds of useful things. We go down here to the bottom, towards the bottom, to something called T-surf.
A bit more.
Yeah, I know, Jesus, indeed, it's scary, huh? This is what happens with the legacy model. People keep adding things and never remove anything. So here's T-surf.
Well, actually, most of this is still useful.
I agree. We do use most of this stuff. That's not true. I have used most of these things. And here, I don't know. Hopefully, people online can see this.
No, they won't.
They won't. So, okay, let me stop that share and add.
Why don't you share your desktop?
I could share my desktop. Yeah. Let's see. Desktop one. How does that?
Yeah.
All right. Here we go. So here is a default Earth run deck, and you can see surface air temperature in centigrade. It gives you the mean, the max, those good things. And we could spend hours talking about Panoply and all of these features. You can see all these tabs at the bottom where you can change the scale of the model. You can change the kind of map that you use if you're really into, rectangular, polyconic,
whatever it means.
yes, exactly, whatever this means.
To be clear, that temperature map is the average over the last 12 months of the run?
This is average over 1 month. I only opened up the first month I generated.
Depending on which file you open.
Yeah, depending on which file you open. So if you use some files and you wanted some files, say 10 years of a run, then you could open that in Panoply and you would get the 10-year average for that run. This thing has huge numbers of features. You can change your overlay. For example, here, paleosturtian. Here's a paleosturtian overlay for those of you that can see it. I think we have Venus overlay, if you want to do Venus, and then we have Mars overlay. So there's different overlays. To generate overlays is a pain in the butt, and I won't go into it. There are, again, many other features here. We could spend hours. It has a lot, I mean, a lot of these, actually, I would say most scientists in this building use Panoply to generate publication quality figures. So it's totally possible to change the title and all kinds of things. And in fact, there's even a command line version of this. So you can create scripts. So once you've generated one of these.
Is this out of beta?
It's out of beta, I think so. I don't know. I use it every day. You can export.
It's still secret.
I think it's still in beta.
Yeah.
I think it's
So
downloadable.
you have to ask Robert Schmark politely, and maybe he will give it to you.
Anyway, you can export this as what's called a CL script. It's a JavaScript basically, and you can run. If you write the developer, he will send you the source code for running the command line. So let's say you want to make 10 different plots, roughly the same thing, but just different input files. You can generate scripts to generate all some things that are possible in the scripting language, which are not possible in the GUI, in fact. But it's not. Okay, the documentation for this is way better than our model, but it's still not 100%.
The Hemis variables.
What hemisphere? So you want to look at more things?
No, just one line down, Hemis.
Yeah. So these things, you can use the NC dump command to just look at temperature over the entire planet. If you just want to get a number out, you can also get it from the PRT file. And here you can get the global, I think is it
So it is
global T-surf.
so the dimension of this is, as you see here, southern hemisphere, northern hemisphere, global mean. So the first number is the southern hemisphere mean, the second, the northern hemisphere mean, and the third one is the global mean, of course, area weighted.
Yeah. So if you just want a quick and dirty look at what the surface temperature is, you can just use NC to pull out from the bottom of the dump exactly what the temperature is. You don't have to open this big giant program called Panoply to look at this.
And you don't have to even write your own code. If you only care about global mean values, they are right there, only for the IJ files.
Only
so
for the IJ
if you want if you take a 3D file, which is an IJL file, it does not have Hemis variables. And it's a feature I am requesting for a while from the relevant people, and I hope we will have it one day.
Yeah, these are all the different hemisphere variables that are available in those AIJ files. If you just want to get a quick and dirty view of any of these things.
And then
water cloud.
The diagnostic names are not always intuitive, but the long name is most of the time very helpful. So if you do an NC dump and then grab some keywords, you will find easily which is the variable you want.
I'm accumulating a long list of really stupid questions that I don't have in front of an entire group of
Yeah, you
people.
should.
Totally do it.
Totally do it.
When it's the same list.
So let's go to Q&A. I think we've covered all the material we wanted to today. In fact, I thought it would be go faster, but
There was one question about how to start the model on clusters. I can just briefly show one line in model ERC that people should be using.
I would find that helpful.
Yeah.
I don't know that. I want to keep notes now.
so you have are you running Zoom?
Yeah. If
So then share your desktop. I will stop sharing mine.
Yeah, you go here. No, not here. Go to the other window. That's the microphone.
this one is up.
An LL and all that shit. Like that doesn't run on my badge.
Select which we are sorry.
NC dump should have been installed. LL is a shortcut that I've written as shell
Okay.
script.
I say it here. Am I?
Yeah.
Oh, okay. No, it's fine. Can you blow it up?
Can I blow up what?
Here, just click that.
Oh, you want me
Tiny
to
little
show this? Sorry. Okay.
Okay, so
Let me close this.
this. Okay, so just close it again. So basically, let's see. Yeah, so I'm just looking at model ERC file, and this
Dot model ERC file, which is one of the files we asked you to edit it.
Yeah, so here is all the stuff that we asked you to put in, the standard stuff. but there are certain things which are not documented or maybe like poorly documented. So basically, well, I have a lot of stuff here, but
Don't show them that.
but basically, what you are interested in is this line, which is called substring. Let me see. Yeah, Q substring, just without an extension. So
That's not in my file.
Huh?
Yes, it's not there. You should be adding it.
Got it.
Okay. Maybe there is some documentation. I just have to remember where we put it. But technically, not that many people actually use it, so that's why. So what it does, basically, if you are worked on big clusters, and usually they have some system to submit jobs to queue. On Discover, we worked with two systems, it's PBS and Slurm. And basically, it looks like nearly every system, they have different ways to submit the job. And one of the ways they allow you to do this is basically execute everything in a single command. So what you do, you create a script file which starts your job and basically put everything in that script that you want be in your job. And then you specify some certain command which is specific to this scheduling system, and give that your script to this command to submit it to the queue. So with Slurm, this command is as batch, that's basically Slurm batch system. Then a lot of flags, and then at the end of the line you specify your script. Like here would be my script to execute. So basically, this Q substring, what it does, it specifies this command exactly as it's supposed to be specified on the command line by the scheduling system which you are using, except it doesn't have this last argument, which is your script. So that script is created by our system, and it will be substituted automatically. So the only thing you need to know this command which is specific to your cluster. For our cluster, it's as batch, then dash QoS. It's
Explain what these things are. Yeah.
Quality of service. That means basically what kind of queue you want to use. So here I'm using debug queue, which has certain restrictions. Then -A on our system means this group you belong to. I have permission to run my runs as a group S1001. So I have to specify it so that Slurm recognizes me. Then Slurm is very smart in the sense like how to distribute the resources. So I don't have to tell it much about what I want to do. I just say that I want 88 cores, and I specify it with -n 88, and Slurm defines itself how many nodes it has to allocate for me and everything. Then I want to be here a little more specific. I don't have to, but here I specify that I prefer this kind of nodes, that is Haswell nodes, and then I specify for how long time I want my job to run. And since it's debug queue, actually I cannot run for more than 1 hour, and that's what I'm specifying here. -t 1 hour 00 minutes 00 seconds. And for Slurm system that we are working on using on Discover, that's pretty much it. So if our scripting system finds this the substring in your .model ERC, it will use it automatically with all run E when you use run E scripts that we showed earlier, or which you already used if you compiled the model. So with this cube substring, it will be doing this thing. There is some modification to this thing if you want to go like deeper in details. We can actually specify number of processors and time on your online when you use run E. So instead of static values, you put here this like %NP and %T, and then on a command line you just specify -n, as I remember, and -T. and specifies the same variables here and here. So yeah, and this underscore something that's the suffixes that you can specify also on a command line, and you specify it with -s.
This percentage NP, what is that?
That means input from the outside.
Yeah, these are two.
Why don't you give an example? Can you just write on the command line what the input, what it looks like?
I can
when
just
you use it?
recall something that I was using. For example, this is one of the examples that I was using just because the last command that I executed. So I want cold restart on, actually it's NP, so number of processors 88. Then I wanted to run it for 6 hours, and this -s gives dev, that's actually a suffix on the Q substring that was in model ERC. So you may specify a lot of those Q substrings in your model ERC, and you give them suffixes, and then you can call them by suffix from the command line. And that's pretty much it. That maybe this is not very.
So if you show this to your local admin, they will know what to do.
Yeah, you have to talk to your local people. You shouldn't be expected to know.
Unless you know it already, you don't have to figure it out.
Every
there are
Q
people that
system
know.
is different. Everybody actually, even if they use Slurm or they use PBS, all of which we've used, they might set it up in a different way. They may use different option names. All that's possible. So talk to your local people. You shouldn't be expected to know what all these options are for your queuing system.
Yeah, I'm just trying to find something more. Fortunately, all my rounds are slightly specific. Oh, anyway.
Okay, well, why don't we take?
I guess I give you the example. You probably don't want to waste everybody's time.
Why don't we just take some more basic questions now, so that before we go on our way. Yeah, Stephanie.
88, a typical number.
Okay,
I
depends
think
on model
last
resolution.
year you said 44.
Yes. So for 4x5, 40 layers, we recommend 44 cores. For if we go to the high resolution model, which is not available yet, the F resolution, the 2.5 by 2 by 2.5 model, they 88.
Okay. And
The rule is number of latitudes minus
-2.
2.
Yep.
Yes.
Okay.
Latitudes minus 2.
Good. I was afraid I had been running suboptimal for last year. That's good. I got it.
You know, there is also the issue that depending on the model configuration, you might not want to go to the maximum amount. On your computer. So if your computer is very limited in CPU time, and then you end up being queued a lot because you're requesting for 44 processors, going for 23, for example, which is not 22, 23, means that you will be higher in the queue because you are requesting less resources, and you will not be terribly slower because certain things need to stop being parallel too frequently. So it depends. So when I was doing years ago some benchmarking about different configurations, I was told that for the cheapest model configuration ever, I should not be using 44 because that actually slows down the model. But it depends on your computer. I would say that if you don't have a limit on CPU time, go for the maximum.
Well, if you run the model with Socrates radiation, you probably should go with the maximum because
yes, absolutely.
parallelize as well, because
absolutely.
mostly it would be single column radiation will take a lot of time. If you, for some reason, decide to use ROCKE radiation and you don't do anything fancy, then you may go with lower number of CPUs because it will be mostly dynamics, which will take time and it doesn't parallelize that well. So going from 23 to 44 CPUs probably wouldn't give you much. Actually. This common is like the most typical for.
Well, I mean, we know that the model runs best at 44 cores if you're running 4x5. There's no reason to do an efficiency test. It is the highest efficiency.
Yeah. The highest efficiency is 44
Yes.
unless you are being queued too much because of your computer.
Yeah, but it's difficult to explain that. I mean, what he means is that if you're on a supercomputing system and you can't get your job into the run queue, you will sit in the wait queue for a very long time waiting for 44 cores. It could be that on your particular supercomputing system, the wait queue is much shorter if you only ask for 23 cores. So instead of waiting a week for your job to get into the run queue, you submit it with 23 cores, and even though the model may take twice as long to run per time step, you'll be done before the people waiting for 44 cores ever get their job in the queue.
Yeah.
Is that understood? Yeah, okay.
Okay, so we have a question that is clearly for Igor on the chat window. Is there a way to specify wavelength-dependent surface albedo profiles for given surface types?
Yes, albedo.f.
Well, in that sense, of course, everything is possible.
There's a table, right? There's a table. There are tables.
Yeah, well, there is a table. Yeah, I guess you can do it there, but it's also limited. I mean, we have only 6 bands at which we are working. But
Okay,
yeah.
I think we should take this offline. This is a very technical question. Let's talk about more basic questions because that you should just write Igor if you want the answer to that. I don't think that's too technical. Can we talk about things that we discussed during the tutorial?
But we should know the limitation, right? We have a number of wavelength bands.
Yeah. Maggie.
Question. So